So I didn't get anything done this week. I just looked at some plot juggler plots and back to the same problem, trying to get my vehicle or Al's vehicle to run around in the yard. Get your physical vehicle to follow a path. And for some reason, it works in the simulator and does not work on the actual vehicle. And I keep looking at numbers, and I was thinking maybe the steering isn't responding quick enough, so it tells it to turn one way and it doesn't do that. And I thought maybe just take it out and drive it around really slow, because that would be the equivalent of speeding up the steering or just slowing down the vehicle. Either one should make the steering work better. But when I go look at the plots, I can't really tell if that's really the problem or not. So that's why I just want to take it out and drive it around and see what it does. And just looking at the plots coming out. Oh, back to the concept between the simulator and the actual vehicle. I decided that would be one thing that would be different, and is your physical vehicle, may not respond the way the one in the simulator does, because the one in the simulator probably, if I tell it to go from hard right to hard left, it'll probably do it very quickly. But I think in between there, it's got that, to get that simulator to work, I used a piece of code that was called Ackerman controller.py, and it takes in an actual Ackerman message. And one of the fields in there, you can tell it how fast you want the steering to go. So I could actually slow down the steering on the simulator. I've got that little intermediate converter node. I can just go in there and just jam in a thing saying, don't turn any faster than this, or that might even be a parameter on Pure Pursuit. You can go in and say, what's your steering rate or steering speed or something. And, up to this point, everybody's been ignoring that because they just want the steering angle and the velocity, so they don't really care. But the one on the simulator does pass all the way through, so I could slow down the steering on that, and again try to break the simulator to get it to that'll prove one way or the other, if it has anything to do with the steering or not, I guess, on that. And other than that, I just came up with some thoughts on things to look at. I was looking at some plots. I've got the one where I specifically went out in the yard, pointed my vehicle north, and then the starting point was 3 meters off to the left and about, I don't know, another 3 meters off to the north, or what, off to the west and the north, or the left and up on the screen, I guess I should say. And I just need to, I plotted that one, so I've got the data for that, and then I can run that same thing on the simulator, and I got the data for that. And of course, the one on the simulator looks right and looks like, why wouldn't it work? And then I look at it from the vehicle, and I'm either missing something or one thing I just looked at this morning, I noticed that if I pull up, I was going to pull up a plot and say, okay, here's what I did, but I didn't get around to doing that. But I thought, well, let me look at the speed of the thing so I know when I'm moving and not moving. Because since I'm controlling it with my joystick, Al just lets as soon as he says start Pure Pursuit and publish a path, Pure Pursuit just puts out whatever value you put in your maximum speed. It just publishes that the entire time. Mine, I just switched over, so when I say go, I can move my joysticks. So I'm actually controlling the forward velocity of my vehicle with my joystick, and not just leaving it at a constant value like Pure Pursuit currently wants you to do. What was my point on that? Oh, so when I was looking at it, I think I pulled up, this might have been the one from the simulator. I pulled it up and said, show me the speed. My speed didn't look right. So I said, give me the speed off the odometry statement. And that odometry statement is being generated by that GPS to odom.py. And I was thinking that I purposely didn't even put the speed and the rotational velocity into that, because I thought, well, Pure Pursuit's not using it anyway, so I didn't do anything with that. So I don't know why it's got a speed value in there if my code is not putting that in there. So that's something else I can look at. Just, say, is there something in there that's being missed, or it's picking up the wrong values or something? So again, I just got a bunch of things to look at if I just get around and do that. So I think that's all I got to report for the moment.
That speed thing, if you're not putting speed in the odom, I'm just thinking there's also a transform, publishing a transform in that GPS to odom.py. And I mean, you might be onto something there. I was just trying to look quickly at mine to see if I had put any sort of speed data in mine, but I didn't get to it fast enough.
Well,
Yeah, but then,
that transform that it publishes does not have speed in it. It's just simply got your XY position and your rotation is all that gets published on that transform. So
oh, okay.
once that gets into pure pursuit, it says, "Oh, I just got an odometry callback, but we're not going to use the odometry information. We'll just pull the information from the transform tree." And I verified that that is working correctly. If you go into the code where it says, uh, "Show me the transform between map and baselink," it gives you the information. And then if I plot that directly on top of the location from the odometry, those line up. So that is coming through correctly. So that transform coming in, as far as I can tell, is showing us what it's supposed to for that incoming data.
The other thing I'll just ask you, sort of regarding that, I'm just going to pull up my screen here for a second. Share. So this is come on. This is a TF tree that I printed off this morning. In the, I don't remember which is producing this look ahead node. But do you think the look ahead node should be coming off of base footprint?
On mine, I see it comes off from base link. And my stuff that I put together, I don't have base footprint on my physical vehicle, but it's on my simulated vehicle. But I think it comes off, look ahead comes off from base link.
So you have mapped ODOM to base link, no base footprint.
Right. That's what I've currently have. And another interesting point, that look ahead transform that gets created, as far as I can tell, that never gets used for anything other than you can use it in RViz. It'll show you on the screen where it thinks that point should be. But they what they do in the code, they say go from map to base link to tell us where we are now, and then they say give me a transform between the point, the pose point in the path array. So whatever the current point is we're driving to, it does a transform between that and base link. And the only thing it saves off from that is that YT value. That's the distance from the right or left of your vehicle from the point that we're going to. And otherwise, they go ahead and publish that look ahead transform, but I don't think anybody's using it for anything. So
Okay.
regardless of where that's coming off, that might not be a problem. So let's see, that would be that would probably be in your peer pursuit. And there's going to be a parameter in there that says something about what's your vehicle called. You can either call it base link or you can call it base footprint. And you're probably telling it, maybe in your startup stuff, you're probably telling it to it's like in a launch file, you're going to say start pure pursuit, and then here's what all these different things are called. Either that or there might, maybe pure pursuit has a parameter file. I always have to go poking around to find this stuff. So
Yeah, and I've got a couple, let's see. So this is my launch file for starting the Larry's Pure Pursuit. And
right there in the middle where it says look ahead frame ID is look ahead, and then above that it says so 2 lines up it says something robot frame ID is base footprint. You can probably change that to base link and it'll just bypass the base footprint completely. So that'll then put it where it's supposed to be on your just change that to base link, I think is what that should be called.
Oops, that didn't do what I wanted it to do. Okay, well, I just wanted to share that. I stumbled on that when I did a TF tree and thought I would share that with you.
And just until a couple days ago, I didn't realize that base or the look ahead showed up on the transform tree at all. And I noticed, oh, there it is. And on mine, it was coming off base link simply because I don't have a base footprint.
Okay,
And while you got that up there, I realized why in that code it says we're not going to use the odometry message coming in. We're going to go to the transform tree. It's because on the um, if you use the ODOM message, ODOM is going to say, in your case, it's probably going to say ODOM to base footprint is what it'll say that's the parent link and the base link. It'll say ODOM and base footprint. And what that does, it says that's the difference between those 2 points. Now at the top between map and ODOM, we currently have ODOM map right on top of map. So they're both at 0, 0. And then down at the bottom, base link is mapped on top of base footprint. It's just that base link has a vertical offset from the ground is the only difference between those. So in our case, since we have the top 2 mapped together and the bottom 2 mapped together, the only difference is ODOM to base footprint. Now, if you had something else going on, say if you run an AMCL and it's nudging around these odometry markers, so it's no longer on top of map, so it can pick up any arbitrary offset as you drive around. Well, if you just simply use the ODOM to base footprint, that's not going to take that into account. But by doing a transform between map at the top and base link at the bottom, it accounts for any changes in between those. All those variables going on. That's why they did that. That's why they went to the transform tree instead of taking the incoming odometry message. But now, since the stuff that we're doing, we've always said, create an odometry topic and create the odometry transform both off the same sets of data. It's kind of just transparently falls through here, and that's why it'll still work. So regardless of where you put that look ahead, I don't think anybody's even using that other than it's handy on RViz to put up on the screen and watch it move around.
okay. Well, my status is best summarized by activity but no results. Um, so as a reminder, this plot comes from a little simulation tool with pure pursuit that was written by this guy, but I have it here simply because it's convenient. And so again, we've got 2 simulations that look right and run perfectly, but one this simple simulation and the other the gazebo simulation, but in the real world, it's not doing that. I have at the moment sort of 3 different options on trying to get pure pursuit to work. This is the C code from what I'll call the lyrics. Hopefully I'm not mispronouncing that. Pure pursuit, and it uses this KDL stuff, and as Jeff was talking about, uses this dynamics library to ultimately calculate a steering angle. And I added just some informational descriptions there. In trying to understand that, went out and created another program that we'll call it the hard coding or the sort of the brute force way to calculate the steer angle using hopefully the pure pursuit program. And again, the results are not, it's not following a path. And so in addition to try to, I pretty much paused on looking at the, I'll call it the Larix or KDL approach. I spent the last week trying to look at, my, call it the DIY approach. And I've got a couple of plots out on mine. Let's see if they're worth talking about. Yeah, I'm not. So I simplified a path and I just said, okay, can we try to make a left-hand turn? And went through, a little bit more analysis of just trying to make a simple left-hand turn. And, went through some plots of in detail what was going on with the current position of the goal point and the path that was being followed. Bottom line is, I'm not any closer to a solution. This is an example of when this little green dot, so it's going straight, and then the path makes a left-hand turn, and until this green dot goes over that path, it's not going to try to turn left. And by that time, it's way out here. I say way out here. It's a meter or so out here, right of the path. And then it's going to start generating, negative steer angles, which is what it should. But I'm describing the problem, not a solution clearly. But at this point, it knows it's supposed to start turning. Well, it doesn't know that it's supposed to start turning left as the plot shows. At that particular time value, it's still generating a negative number, which in our nomenclature is a right-hand turn. And not an insignificant right-hand turn. That's a pretty substantial right-hand turn. But as you can see, it's obviously off the orange dot, but it's not off this. It's not to the right of that path, which would come down here. So it's trying to get over to that path. Oh. So I had a couple of hypotheses that maybe if I changed the look-ahead distance or added more plots, things would be different. And although those might be reasonable, I haven't necessarily tested those yet. So it's just some of my journey and trying to get down to what to do. And as you would guess, in the simulation, it runs perfectly.
Yep. Can you zoom in on that one you had that had the green loop on it that you just had up? Yeah, that one would work too, I guess.
This one.
Yeah. And as you say, it's driving along and you say it doesn't change until it crosses the path. Well, it seems like, this thing should be recalculating each time it comes through here. It should be created a new path each time through, and it shouldn't have to wait until it gets, as you're pointing out, if you look at the plots, when it tries to cross the path, and that's when the polarity changes and start trying to turn the other way. But it just seems as you're driving along up to that point, it should be recalculating, every time through there. And I think that's going to be controlled by, um, it's the pure pursuit, the lyrics pure pursuit is triggered by an incoming odometry message. And since we created the odometry message from the GPS, at whatever rate your GPS is publishing, I believe yours is running at 10 hertz, and I believe mine are running at 5 hertz. So either 5 times a second or 10 times a second, it seems like it should be saying, create a new path every time through that loop, and not wait until it gets all the way to the the path and crosses it. So that's just another observation I had, that it just seems like, as you're driving along, it should be constantly, making a new path. So as you're getting close to the line, it should be, trying to drive up to the point up above and not go across and go to a big loop to get back to there. So
And so I would agree with you. And my, doing the DIY code has really just been about trying to understand it in my own head. In this sake guy, in this visualization simulation tool that Kyler mentioned, a long, long time ago. Let's see if I've got his core code. I'll just, since you mentioned it, I thought it's worth noting. So he's got this pure pursuit function, and its purpose is to return, he calls it delta, but it's, you'll notice this is a pure pursuit algorithm of wheelbase times the angle, the sine of the angle to the goal. I think that's look ahead, or one of those is look ahead. And in that process, he calls this function to get to the target, which is the point on the target that he wants. And yeah, I added some comments here trying to understand his code, and it appears to me that he's going through every point in the mission and calculating the distance for every point so that he can choose which is the closest point. So there's his math for, or process for calculating that closest distance. So yeah, he has an approach that I don't have for calculating that, what's the closest point to the current point on the path, if that makes sense. So, and I couldn't see where in the KDL stuff that sort of thing was going on. So
that is in there. It's when it first calls that calculate velocities, which was a callback from ODOM. Right under there, it says go out and do the transform between map and base link. And then the next thing it says is go up a couple lines. What function are we in here? Keep going up till this one starts. Right, so right there. So compute velocities. Again, this is called by ODOM, even though it's not going to use the ODOM stuff. So it says try, and then it says go get the transform between um, map and base link. And then the next line says for semicolon index less than path poses size to index plus plus. That's doing the same thing right there. So it goes
It's going
through.
through all of them.
So it's scanning through the array, and then the very last thing down there says break. So apparently, if it finds the one that's the distance is looking for, it breaks out of this. But that's doing the same thing. Each time through the loop, it's going out and scanning on the path out there to find. And I don't know if it's trying to find the closest one, or it's just it's basically trying to say, do we need to increment the index is what this whole thing is doing here. So based on your distance from the vehicle to the point that's pointed to by that index, the index is just moving up your path as you move. And apparently it's just looking for that condition where it said if the distance is greater than LD. So if it is, then it calculates something. Otherwise, I think it just it increments to the next thing in the for statement. And once it falls, then once it finds what it's looking for, then a couple lines down past the bottom of the page here, it says break, which means once it finds it, see it doesn't break, that kicks it out of the for statement. And then you fall through and start doing other things. So it's doing things like say, are we at the end yet? Or are we getting close enough to the point we need to increment it to the next point? And then there's another step that where it's got the whole bunch of code thrown in there. It says something about we're approaching the very end, but we don't have another look ahead point to drive to. So he's got like 10 lines of code that generates a new point, which seems rather complicated to me, but that's so you got one section that's just keeping track of the points in that array. In other words, selecting which pose do we want to drive to. Then you got the other code that says we are here, the target is here, generate steering angle. So you got two different things going on at the same time there. I don't know if any of that made any sense, but that's
It does. I mean, I remember seeing that sentence and trying to decompose it. And you're right. I think I had, although I probably could never write that line of code, I think I finally did. Now that I think about it, come to the conclusion that he was going through all of those, all of the effectively waypoints in the mission.
so that line there says for something. I looked at that, and since it says the first field is empty, so it says for an empty field with a semicolon, and the next one says until we reach this condition that says till the index is less than the poses. So it's gonna start from wherever you're at. It's gonna increment until it finds the last point, and see it says if we haven't reached the end, we're gonna increment it. And then we do all this testing below. So it's simply, I think it's saying start at wherever our current point was defined as, and start moving forward until we find one that falls within this testing here of something the distance greater than LD. So I think once you get to the point that says, okay, I found the next point on the path, then it calculates these values for it down here and then breaks out. So I don't think it'll scan the entire array unless it doesn't find any points on there. If it can't find any points close enough, then it may scan the entire array and then just give up. And kind of like the one plots that I plot them out and I see the path that's generated, part way around the circle and then it was cut off. That's what happened there. It got lost looking for the points. And then you come back around and say, oh, here's the next point that's closest to me. So it picked back up and started following the path again.
So, I'm still at the plate swinging the bat. The other thing I'll just quickly mention is, this was an interesting article or paper to read instead of what I'll call the legacy pure pursuit. They walk through a couple of other, I'll call it slight tweaks to pure pursuit. And this regulates the velocity of the vehicle, which they made it sound like that was novel, but I think the Larix solution has the ability to regulate velocity. But anyway, I thought that was an interesting article, but it's ROS 2 nav 2 stuff, and I looked at their code, and it, I'm sure, is wonderfully elegant and concise and all of the things you want to be when you're writing code. But it probably was a computer science PhD guy that wrote this darn thing. So it was not. I haven't, I looked at it a little bit, and they had multiple multiple files, and I was like, well, where do you calculate steer angle? And I decided I was going to spend any more time on it because I was going to be able to use it. So anyway, that's where I'm at.
One thing I just noticed, I see on Slack, you just took the default color scheme that they gave you. It turns out if you go, or yeah, on Slack, if you go into Slack and pull up the properties, you can say theme, and you can pick one called Big Business, and it gives you kind of a gray and blue that looks a little less clownish. So if you're in Slack, you go to the top where it says tractor automation, a little pull down arrow. That's where they've hidden the preferences. You have to pull that up.
Back to Slack.
So right at the top there where it says tractor automation, the top of the pink section. Yeah, right there, pull that down. And it'll say preferences. And then say themes, which is down 2. If you go scroll down, see that they just trying to make it as nasty as possible. Right in the middle, it says big business. You click on that one, that gives you a theme that you may or may not like that more. I don't know if you like all the pastel colors and the silly combinations.
They must have just changed, because I think last week the screen you're seeing is on my tractor, and I don't think it had changed over to that.
It just seems to take a while for the stuff to propagate around. So, in fact, a really interesting thing I found, say if you go down the bottom where it says messages and you start typing something and you got another computer open, all of a sudden, whatever you type it in, bam, shows up on the other computer. And I didn't realize it was doing that, which means, even if you don't send anything, whatever you type in here, it'll just randomly grab that, pull it up to the NSA. They say, oh, we don't care. And then they push it down to your other one. And that just seems odd that it does that, but
So it's synchronous. If I have two Slack, if I am logged on to Slack in two different places, you're saying if I start typing here, it'll show up on the other side.
it did. It wasn't doing it as I typed, but just I typed out a message. I think it was this thing saying that the meeting's going to start in an hour. I had that up on the screen. And then I noticed all of a sudden on my Windows box, all of a sudden, bam, it popped up in that screen. So, before I hit send or anything.
Yeah, so much so for spies leaving messages in the draft folder of their computer.
Rather than making it really useful, they're spending their time putting all their pastel colors and copying all the stuff that Microsoft tried to when they tried to destroy everything. They're doing that, and then they said, oh, let's add this other feature that people won't even know there is there until it comes back to bite them. So that's just more of my complaints about Slack, but that's just what we have.
So my next tests are to maybe adjust the increase or decrease the look ahead distance, increase and decrease increase the step values and the number of paths. Let's see if that has any impact. So I guess that's where I'm at.
I guess I may go out and drive around slowly, or I might look at my plots harder, or yeah, I'll just pick something and see if I can make it work, I guess. So anything else for this week?
Nope, I don't think so.
Okay.